everyone, welcome to this video. So today I'll be discussing the subsets problem on Leetcode. So let's read the problem first. So given an integer array nums of unique elements, return all possible subsets of the array nums. And the set should not contain duplicate subsets, and you can return it in any order. So let's first start off simple, right? Let's talk about what is a subset, or what is a set first. So a set is an unordered collection of items. So this is basically what a set is, and unordered is important here because the reason why it's unordered is because if you have, let's say, 1, 2, right, as a set, then and you have 1, 2, 1 as a set, for example, these two sets are identical, basically. So they're pretty much equal to each other, right? So that's another reason why in the problem, let's go back to the problem now. It's another reason why in the problem they say any order, because technically sets can be presented in any order and they would be the same. So yeah, so without further ado, let's talk about the premise of this question, which is a subsets or subset. So subset is basically a set, except you can pick any items from it. Pick any items from a larger set. So any here can also refer to none. Like there is a chance that we will pick no items. So let me give you some examples here. So let's say we have 1, 2, 3, right? And let's start coming up with subsets for this. So, well, you could pick 1, and you could not pick these other ones, 2 and 3. Alternatively, you can just pick no items. This is also a subset. You could also pick the first item and the last item. It's also a subset. And you could pick all 3 of them, which is yet another subset. And obviously, we can keep going. We can keep doing this for how many ever combinations there are that we have. So that is the essence of a subset. That's what a subset is. So now we have to think about how we can form such a thing given the entire set. So how are we going to form these subsets? Well, we can notice how we form one, right? We have to go through a series of decisions here. So for 1, we say, oh, we'll pick 1, right? We pick 1. And for 2, we could either pick it or not pick it. In this case, we don't pick it. So we don't have 2 in it. And we have to do the same thing for 3, obviously. We can't just ignore 3, right? So I can either pick it or not pick it. In this case, we don't pick it since we only have 1. So these are the kinds of decisions we have to make. And let's do another example. So let's try to come up with the empty set now. So for this one, we have 2 options. We can either pick it or not pick it, and we choose not to pick it because we don't have anything there. And then for this one, we choose not to pick it, and this one, we choose not to pick it. So now we know we can form a subset by coming up with 2 decisions that we have to make. So like one decision is either take the element or not take the element. So how can we implement this programmatically? So we can use something called a decision tree to do this. So what is a decision tree? Decision tree is a model that you can use to model several decisions that you'll take before reaching the answer. So in this case, we only have 2 decisions we can take. You can either take the element, represented as yes for taking it, and then no for not taking it. So the right side will take and the left side will not take. So let's think about this. So if the array, we'll use the same example as before for simplicity. 1, 2, 3. So you can either take it or not take it. In this case, we're going down the yes branch here. So obviously we'll take it. So we have 1 in here. And we're going down the no branch here, which is nothing, right? We're not going to take anything. In this case, we're at index 1. So this is, let's keep track of where we are. So this is index 1. So we choose not to take it. And let's go to the next branch now. So we'll update this index here to point to 2, and we'll keep moving forward. So we choose not to pick anything here. For this one, we choose 2, this second index. Here we don't pick 2, and this one we choose 2. So right now we've completely filled this entire row, so let's continue to the next index. Next index will be 3, right? So in this case, we don't pick anything. In this case, we pick 3. In this case, we don't pick it, 3. This case, we do, 2, 3. It's good. I might run out of space a little bit, but we have 1 here. We don't pick anything. We have 1, 3 here. In this case, we don't pick 3, right? 1, 2. In this case, we do. So yes, this is the full decision tree. And keep note of how many items there are in this final layer of the tree, or all the leaf nodes, if you can call it that. Yeah, all leaf nodes. So notice something here. We have 2 here. We have 2 here, 2 here, and 2 here. So yeah, in total here we have 8 leaf nodes here. 8. So we know our answer, or how many subsets there will be, are 8. And right, you can also verify that all of these are indeed subsets, because we've taken these items from this larger set here. So yes, all of these items are indeed subsets. So now the question you might be asking is, how can we code this, right? How can we code the decision tree, and how do we build it? So let me discuss this now. So we obviously start with nothing, right? Start with nothing. And then if we take this no path, right, we go obviously to nothing, right? But here's the key, right? If we go to nothing, right, and we don't like trace back to this one, right? Let's assume that we continue going down this path, right? So what will end up happening, right? You'll choose, oh, you'll be like at this index and say, hey, I don't want to take this, right? And you'll continue going down this path, right? You'll keep incrementing the index and keep going down the path. And what ends up happening here is you just get this long line of just nothing, right? There's just nothing you pick, and you don't get the answer, right? You only get one of the subsets. So what you have to do here is, this is the key, right? This is what you do here. Let's say you're at this index, right? Index 1, and you say, hey, I don't want to pick this. Or actually, let's think about it like this, right? You go here and then you choose, oh, hey, I want to pick 1, right? So I want to pick 1, right? So how do you model this other side of the tree, right? So what you do is you pick one, right? And then you somehow have to go back here. So what you do is remove one from your list. Let's say you're building a list, right? List that contains the subsets. So since you added one, right, you have to backtrack or go back to the parent, right? Your last action you've performed so that you can access these other branches. So you remove this item one, right? And now look at that. You can go back to having nothing again. So in other words, you can undo what you've done before to create another branch in the tree. So that's the idea I'm going to be using here. So you have one here, you go back to the root, and then look at that, you have nothing here. Um, and then you could do the same thing for this other like layer, right? You could go back here. You could go back to this point. The index here will shift up one to represent the other item. You could pick two, 1, 2. You could remove this last element, right? You'll go back to the parent, right? And you'll choose here, you're at the parent, and you'll choose not to pick anything, right? And then you're here, you can go back to the parent, come here, and choose nothing. Go back, and you can choose 2. And this kind of process here will keep repeating down the tree. And what you'll eventually end up with is a tree just like this. So this tree is basically like this. That's how you form it programmatically. So let's think about what we've done here. We've added an element, right? When we add an element, we have to go back to where we were before in order to gain access to more paths down the tree. That's how we build the decision tree from the ground up. Okay, so that kind of explains the problem. Now I will walk you through the code. So I've coded this in Java. You can code in whatever language you'd like. This problem is not really, you know, it's not really any easier to code in Java than is Python, for instance. So that's what we're gonna do here. So let's see. We have a power set here. Basically another way to create a subset, or I mean, a list of subsets would be a power set. That's what it's called in mathematics. So I just named it power set. You can name it whatever, it doesn't matter. So in here we've instantiated a subset which we're going to create by doing this function. So basically we pass in this subset here. This is an empty set, by the way. There's nothing inside. We pass it here, and we have to keep track of an index, right? Index is very important. So we have this, and keep track of the index, and this is the part I was discussing in the tree about adding and removing. So we just add the item correctly, right? We add the item, and we move on to the next index. This recursive call will go back up to here and then call it on the second item of nums, right? That's what we're gonna do here. But you have to remember, you have to go to the other side of the tree, right? So you remove the last item you've added. So this is similar to what we've been doing earlier with going back up to the parent. So we do this, and then we obviously increment the index because we're moving on to the next layer of the tree. So this kind of logic, or this code kind of shows what we've done here with going back up. So that's what we've done. And we continue until the index is out of bounds. So obviously if you reach the end of the array, right, you want to stop doing it because you've came to the last element where you have to make a decision, right? So this is where you stop, right? And then after that, you add this subset to the answer, which is power set here, and then you return, and yeah, that's the end of the problem. So hopefully you found this helpful. If you did, you know, thank you for watching.